Good morning, ladies and gentlemen of calculus. We've come upon the trapezoid rule, so we're going to talk about that a little bit today for the remainder of class time. And what happens is that there's the official rule is something like this, but to me that sort of overcomplicates things. To me it's just easier to look at the formula for an area of a trapezoid and work with it. Just makes more sense. What is the area of a trapezoid?
Area of trapezoid equals 1/2.
1/2.
B.
Okay, you have
B1
base
plus
1
B2 times 5.
plus B2 times the height. And basically what you do when you work with this formula, it makes things pretty easy. Easier than looking at the official formula. So let's go ahead and look at the applications of this. So here we have the first problem using this. Estimate the integral from 0 to 2 of x cubed dx for n equals 4. And so we have n equals 4. So the way I would work something like this is just set up a little table. So here's a little table. And we know we're going to have x and f of x. And what numbers do we put here for the inputs on the table?
0.
Okay, we start out with 0 because we're starting 0 to 2. And if n is 4 over this interval, what's our next thing we're going to put up here?
0.5.
Yeah, 0.5. And then our next increment is 1, 1.5, and 2. So we have our increments here. So what's going to go here? What's 0 cubed?
0.
0. What's 0.5 cubed?
Is that 0.125?
I think it is 0.125. And then what's 1 cubed?
1.
1.
And what's 1.5 cubed?
Ooh, I know it. Ooh, it's
2.5 times, what did I see? 1.5. I should know what this is.
Well, what's 15 squared?
Okay, it's going to be 75, 15, that's going to be
225. So 2.25.
2.25, yeah.
But then you got to do it again because it's cubed.
2.25 again times 1.5.
Which I don't know that. That's a lot.
So 2.25 times 1.5, that's going to be, you're going to add to it 1.125, right? Because that's half again of that,
Yeah.
right?
Oh, that's smart.
So now you add this up together, you get 5, and this can be 7, 3, so 3.375, is that right?
Yes.
And then this is going to be
8.
8. So use a trapezoidal rule, and so how do we work this out? Well, our estimate of approximation, thank you. That's a proper word because that's the actual word.
I'm one step ahead of you.
Yeah, that's right. Approximation of 0 to 2 x cubed dx equals, how many intervals do we have here? 1, 2, 3, 4. 4. So I'll have this plus this plus this plus this. Are there any units here at all? No, there aren't. So we know that we're going to divide by 2, right? And we know that our width of each interval is
0.5.
0.5. So 0.5 times something, 0.5 times something, 0.5 times something, and 0.5 times something. And what's going to go in the inside here?
0 and 0.
0 plus 1.125, so 0.125, right? And here we're going to have these two added together. So that's going to be 1.125. And here we're going to have these add together. So that's going to be 4.375. And finally, this last thing here is going to be what? 11.375. And there we have this. Now, so that will be our answer. Now my next question is this answer going to be an overestimate or an underestimate of the actual area?
Over.
Okay, Aaron says over. What says anybody else?
I think it's over.
Think it's over?
Because it's 6 cubes, so it's going to be 6.
Okay, why is the thing going to be over?
Because it's concave up. On
Yeah.
that part.
Yeah, okay, so what happens is the function looks like this. And here we have from 0 to 2, we're concave up. So a trapezoid, if we put this in a single trapezoid, that trapezoid is going to be above that curve. So this will be an overestimate.
Nice.
Okay, so we went over some concept, and I like that over or an underestimate type thing. So now, let's look at this one here. Okay, this is a calculator one, and we have a continuous function. So we have values. What is the trapezoidal approximation of this? So I want you to work that out. And there's a calculator one, so after you write it out, you can use your calculator to find your answer, right?
Mm-hmm.
Right?
Yeah, I'm a working person. Are you ready?
Okay, what do we get for this?
I know what I got.
So we're going to go like this, right? And what's going to be the height of these trapezoids? What's our height of the first one? 3, 2, 1. And what's going to go in here?
The 10 plus 30, which is 40.
So 40,
And then 70. Yeah.
and 70,
And then
and the last one's going to be 60.
we do them together. I got 160. No, I don't know.
That's what I got.
Okay.
Yeah, so what you can do is you have 3 times 40, so that's going to be 3 times 40 is 120 divided by 2, that's going to be 60.
And
Then you have
100.
plus 70 plus 30,
And that is 160.
so you should get 160. Is that what you got?
Yep, that's the one. Now it goes more.
It says calculator one, but this is really not calculator not needed, right?
No.
That's not very hard, is it?
No. I think it's fun.
Kind of, yeah, and that's what happens as calculus students over the years. Kind of like it.
What? What did you say?
Okay,
I said it was high. You said no.
next we have number of fish caught during 5 hours. Use a trapezoid rule of 5 to estimate the average number of fish that were caught during the first 5 hours. And that's going to bring up a point. I want you to figure that out. And there's a point I want to make off this in ending class today. Let me see what this is here. Okay, the worksheet. All right. This one here actually introduces a new concept of calculus.
Oh, yeah.
Oh, it does?
Yes, it does.
I definitely.
But if you follow the instructions, just follow the instructions. Because you notice they're not giving you a rate this time, right? They're saying the number of fish caught during a 5-hour period fishing tournament, but it's not a rate of fish, it's just a number of fish, right? So right here, you should get your division by 2. And what's the height of all these trapezoids? 1. So 1, 1, 1, 1.
Friend? Oh, I didn't know
And
that.
then finally, we go ahead and add B1, B2 together. We get for the first one, 22. And what's going to be our second one here? Add these two together. 73. And then the next one's going to be, what's that, 99? And then, is that like 111, something?
Yes.
And the last one's going to be
135.
135. Yet, this is not the complete right answer, because this introduces something called average value. And if you're not using a rate and you're given an amount, what you're looking at is average value. So what you do for average value is you're going to take, it's 1 over b minus a times the integral of a function, so 1, and so we have b is equal to 5, a is equal to 0, 1 over b minus a times the integral of a function, integrate it with the limits. That's the average value. So we're looking at average value. So we multiply this whole thing by 1/5. And this is going to be our average value. And we're going to go into average value later, but in combination with trapezoidal sum, Riemann sum, that's our average value. So we'll be going over that later at some point. And let's see, tomorrow we're going to be doing some more exercises on Riemann sums and trapezoidal rules.
Nice.
Yeah, so that'll be good. We'll be working on that some more tomorrow. And then that should get us through that and get started on note card 44.